Okay, yes, that is correct. All right, so quantum numbers, you know how we said we cannot see the electrons? Is that right? And we said the electron behaves like a wave, and Schrödinger came up with the wave equation. Is that right? And all the explanation of where the electron is in the electron cloud comes by solving Schrödinger's equation. Is that right? And the possible allowed mathematical solutions. Is that right? So we are not going to solve equation, but we are just going to look at the solution that they had for Schrödinger's equation. All right? So when they solved, they said every electron will have 4 quantum numbers. What will every electron have? 4 quantum numbers. All right? So the first one is called the principal quantum number n. All right? So when you're solving for where the electron is, where is the probable region the electron is, the first solution you have to get is the principal quantum number, and that indicates the energy level the electron is on, meaning the distance from the nucleus. Does that make sense? Doesn't the energy level relate to the distance from the nucleus? Yes. So the first thing you have to solve for an electron is its energy level, and that is called its principal quantum number. Musi, how come you're here right now? What are you looking for, Musi? Huh? Your cell phone? It's not here, Musi. Nobody took your binder, all right? Is that your binder at the end of the class? The white one there? You see that? Sorry, Musi, it's not here in class. All right. I think Musi will find his binder. Let's continue. That's Ishmael's, not yours. Okay, let's continue with the lesson, guys. All of you right here. All right? And when you're trying to solve for the energy level, the distance that the electron is from the nucleus, it can have values of 1, 2, 3, 4, 5, etc. Guys, please realize that n cannot have a value of 0. The distance from the nucleus may not be 0. It is only whole numbers 1, 2, 3, 4, 5. The angular momentum quantum number L. What is it? It is L. Indicates the shape or size of the orbital an electron is. So what does the angular momentum indicate? It indicates the principal quantum number indicates the distance. The angular quantum number talks about the shape of the orbital. Is it spherical? Is it a dumbbell? Is it a flower shape? Does that make sense? Yep. And the value, the shape depends on the quantum number n. It can have values from 0 to n minus 1. L can have values from 0 to n minus 1. All right. Let us elaborate this a little bit more in one of these. Let me actually insert a page here and do this for you. All right? Let me insert a page, file. Isn't it here that I insert a page?
edit view language. All right,
Guys, we talked about what are the values n can have. 1, 1, 2, 3, and so on. Are you with me? When we talk about L, what does L depend on? Shape or size. And what are the values L can take?
0 to n minus 1.
It can take 0 to n minus 1. All right? So, n is now 1. 1 minus 1 is what? 0. What is the only value L can take? 0. Are you with me? N is 2. N is 2 now. So what values do you think L can take? 0 and 1. It can take 0 and it can take 1. N is 3. 3 minus 1 is 2. What are the values L can take? 0, 1, 2. Are you with me?
Yep.
Alright? Are you with me so far?
Yes.
This is the first energy level. Are you with me?
Yes.
If L equals 0, it's the shape of the orbital. What shape do you think it is? What is it? It's a spherical shape. L equals 0 indicates an s orbital. Are you with me? Did we just talk about a 1s orbital? Did we just talk about a 1s energy level? Are you with me? Alright. N equals 2. L equals 0. Which energy level are we talking about? 2s. Alright. This L equals 0 indicates the energy level 2s. Are you with me? If L equals 1, which shape of orbital is it talking about? 2p. This is the 2p. Are we good? Alright? Energy level 3. Which orbital do you think L equals 0 and equals 3 is talking about? 3s. Which energy level do you think n equals 3, L equals 1 is talking about? 3p. Which energy level do you think n equals 3, L equals 2 is talking about? 3d. Are we good? Are we understanding? Alright? Are we good? Can we go back? Alright? For s orbital, what's the value of L? L equals 0. For p orbital, what's the value of L? L equals 1. For d orbital, what's the value of L? L equals 2. For f orbital, the value of L will be 3. Alright. So now you're solving for the next quantum number, which is called the magnetic quantum number ML. Alright? ML. Now, indicates which orbital an electron is in. Now, the magnetic quantum numbers can take values from minus L to 0 to plus L. Alright? The magnetic quantum number ML can take values from minus L to 0 to plus L. Alright? Let's go back to this. Alright? When I'm now talking about ML. Are you all with me? ranges from minus L to 0 to plus L. Are you with me?
Yep.
These are the values ML can take. Now, when L equals 0, there is no minus 0 and plus 0, guys. The only value ML can have is 0. The magnetic quantum number actually talks about the orientation of the orbital. What does it talk about? Orientation. There is no orientation of the s orbital. Therefore, it is spherical. Does that make sense? There is no orientation. When you go to L, again it's 0, it is 0, so the 2s orbital, there is no orientation. It's a sphere. Are you with me? But when you have L equals 1, are you with me? ML can have a value of minus 1, 0, and plus 1. Yes or no? Are there 3 different orientations? They talk about the px, the py, and the pz orbital. Therefore, when you have the p orbital, how many are they in number? 3. Does that make sense? All right? When you go to L equals 0, 3s is spherical in shape. Yes or no? When you go to 3p, L equals 1, so ML can be plus 1, minus 1, and 0, which means it talks about the 3px, the 3py, and the 3pz. Are we good? Do we understand it? P, how many p orbitals? How many boxes do we draw? 3. We are now in L equals 2. When L equals 2, what are the allowed values of ML? What are the allowed values of ML? It's minus L to 0 to plus L. Let's do minus 2, minus 1, 0, plus 1, plus 2. Yes or no?
Yeah.
How many different d orbitals are there? 5. How do we know there are 5 different d orbitals? It comes from the solution. Does that make sense? All right? So this will be the d orbitals. All right? We are not doing the dx squared minus y squared. We are not going to do that. These are the 5 different d orbitals. Does that make sense? All right? So now the last and final one is the spin quantum number. So what does the magnetic quantum number indicate? It indicates the orientation of the orbital. Right? Does it indicate the orientation? In which direction is it oriented? All right? So the last one is the spin quantum number. It indicates the direction of spin. Indicates the direction of spin of the electron. All right? And it can have a value of plus half or minus half. Meaning the electron can spin clockwise or it can spin counterclockwise. All right? So, can we go back? Have you written it out?
Yeah.
Okay, can we go back here? And I said, so in this ML, it can have a plus half and a minus half. So how many total electrons can go into the 1s orbital? 2. Does that make sense? Now, if you look at the quantum numbers, there are 2 electrons in the 1s orbital. Is that right? What are the 4 quantum numbers for the 2 electrons that are in the 1s orbital? It's going to be, N is going to be 1, L is going to be 0, ML is going to be 0, but for an up arrow, what is my spin going to be? Plus half. For the one that's down, what are my 4 quantum numbers? 1, 0, 0, minus half. Does that make sense? This is for my second electron in my 1s orbital. Yes, Karan? That's the convention. You have to follow the convention, all right? Now, so if I am, guys, that's what we're going to do now. We're going to assign quantum numbers for different electrons in different orbitals. When n equals 3, what are the values L can have? L varies from 0 to n minus 1. So what values can L have? 0, 1, 2. Are we good? If it is a d orbital, what is the value of L?
2.
L equals 2. If it is a d orbital, did we just discuss that? If it is a d orbital, L equals 2. When n equals 4, what are the possible values of L? 0, 1, 2, 3. If it is a p orbital, what is the value of your L? 1. When n equals 2, L can have values of 0 and 1. If it is an s orbital, the value of L is 0. Alright? For s, the value of L is 0. For p, it is 1. For d, it is 2. For f, it is 3. Okay, guys. I will post an answer key to quantum numbers here. I need you to practice this a little bit more. Alright?